Welcome to T-Lab Innovations. Today we're going to do a little experiment that I've been wanting to do for some time now. Don't know if any of this is going to work, like at all. And we're going to just go ahead and jump into making it before I explain anything. Alright, and I do apologize for the very, very bad drawing as well as how small it is. But hopefully we can get the idea across. So on the left side, you'll see we have a plus and a minus. That's going to be our battery. That then goes into a circular looking object, and that's actually our DC motor. That DC motor has that belt wrapped around it, and that belt goes all the way to the toilet paper roll, or what I'm just going to call our cylinder. And the cylinder has just a bunch of little things on it, and those are the magnets. And as you can see, there's an arrow making it go in a right direction, so clockwise. And as it does that, the magnetic field will actually run past the iron core right there that looks really, really badly drawn, and hopefully with the process of induction, we'll have some electricity. So just to give you a better idea of that, we're going to do it just like this. So south, north, south, north, south. And there's the iron core solenoid, and there's our output. Now we don't know what the actual values are going to be, especially with the magnetic field being very, very weak. And iron cores I have are pretty big. I think that's going to play a part. But nonetheless, it is an alternating magnetic field through a conductor, so it should cause induction, and we should have at least something. Now what I really want to do is see what happens when we take this output and put it back into the input. So not directly into the battery, but like put it in series with the battery. And when we do that, it should make the motor go a little bit faster, because obviously the output's going to be pretty weak. But it should make the motor spin faster. And when that spins faster, technically the magnetic field is changing faster, causing more induction is the question. And if so, how much? So the speed, is there too much speed? Is there too little speed? And how much magnetism is needed from the actual objects? That's what I want to eventually find out, and I don't think I'm going to find it all out today, but that's basically the plan, is to kind of get an idea physically, instead of just in my head and on paper, what this will look like and if it actually does anything, because we got a voltmeter, we can test everything out. So now we're going to go ahead and jump into starting the project. So to be quite honest, with the way I have my camera currently, I think we're going to have to do a bunch of pauses as I actually make some progress on the project. And hopefully that changes as we get better with the videos and get better equipment to do those videos. But as of right now, I'm going to go ahead and start basically putting popsicle sticks around the toilet paper roll and hot gluing them on. And then I'm going to glue the magnets. I'm going to glue them on to the popsicle sticks that are on the toilet paper roll. And we will see how that goes. So, see that. Alright, here we are. So, I went ahead and glued the popsicle sticks all the way around. And then I went ahead and put some electrical tape just to make sure that they weren't going to come off. Now it's time to put on the magnets, so we'll be right back with that. And here is the final product. We got the magnets all on there, hopefully in opposing forces as it goes, and these should be matching, hopefully. Hopefully. So now I'm going to go ahead and work on the part that will make it spin. So basically a stand that'll hold it up and it'll be able to spin. We'll see how that goes as well. See that? So here we have a little bit more of a finished product. We have the DC motor on there. We have some stands. We have the supports for the stands. And they're on both sides. It's not the best, obviously, because you'll see it doesn't go straight down the middle like it should. But it does spin. Now, the next step is going to be using this belt on the actual motor to this part right here, and basically connecting the two ends of the belt together. That way they form more of a complete belt rather than layer over layer kind of thing. We don't want this right there. We want them to meet like that. But it is also too long, so I'm going to have to trim it just a little bit, and then after that try to connect the pieces with some glue and some electrical tape and hope that that stays. I didn't have to use the belt. I could have just connected the DC motor directly to this, kind of like how I did over there to those. But I didn't want to. I wanted to mess with something a little bit different because this is an experiment. I want to experiment with new things, so that's what we're doing here. And we almost ran out of resources. Not that resource. We got plenty of that. This resource, we got 2 left. And I think that's all we're gonna need as far as plastic sticks. Hopefully, this doesn't look like it's gonna move. The metal is too slick for the glue to actually stick to, but I think I got the box on it pretty down tight that it's not actually going to move. Hopefully. I also have some clay I can put around it just to be on the safe side. But I'm going to go ahead and try to work on this belt, and once I finally get it functional, we'll come back. Alright, welcome back, and I had to go ahead and just scrap the belt idea, and we went ahead and mounted it up there. Right now we have everything hooked up. This is another thing I didn't show y'all, but this will allow me to change the speed, that way this doesn't spin fast. I believe we stated earlier that this was crooked, so you'll see, I don't know if it'll show up on camera, but because of that, it kind of makes this part of it move. I've already done a test, but I'm going to go ahead and show y'all what it does. It's nothing great, like at all. It's just, I guess, kind of cool. So to kind